All right, in this video, we're going to be solving exponential equations again, but instead of changing the base, which is what we did the first time we solved them, we're going to go ahead and use logs to solve them now, since we know how to do that. So solving exponential equations, exponential using logs. All right, so for the first example, we're going to do the problem 11 to the v equals 90. So if this was the changing bases day, you would have grabbed your little chart and you would have said, okay, I'm looking to see where 11 and 90 are in the same column so that I can rewrite them using the same base. And then you would quickly realize 11 and 90 are not going to be in the same column, that we would have to have a bigger chart for that because it would be some decimal. And so that makes the problem much more difficult to do if you're trying to do it this way. So instead of using that, we're going to go ahead and say, well, I'm just going to undo all of the operations in the problem, and I can see that my variable is an exponent, and I know that the inverse operation of exponential functions are log functions. So I can see a base of 11 here, and so I'm going to go ahead and do log base 11 of each side. So log base 11, actually I'm going to go ahead and write it. So I'm going to say log base 11 of 11 to the v equals log base 11 of 90. And log base 11 and base 11 cancel. And so we get v equals log base 11 of 90. And depending on the problem, they might want an exact answer, and this would be considered the exact answer. Or they might want you to plug it into a calculator and get the approximate answer. So those of you with new calculators are going to hit math up, log base 11 of 90. Those of you with old calculators are going to use the log button, and you're going to say log 90 divided by log 11. And we'll go ahead and we'll use 3 decimal places, 1.877. And actually, let's go ahead and check the answers as we go today. So I'm going to go ahead and store this. So down here, I'm going to hit stow. So store this. And it says the answer goes to, and then I just have to choose a letter for the answer to be. And I'm going to go ahead and let it be V because that's what this problem was. So V is right here. So I'm going to hit alpha 6. Okay. And so now if I type 11 to the V, then I will get 90. And notice when I did that, when I stored that number, I stored it using the perfect decimal. I didn't round it, because if I round it, if I do 11 to the 1.877 and try my rounded number, I get 90 kind of, but I used a rounded number, and so it doesn't get exactly back to the right answer. So to be able to plug this in and make sure that my answer is perfect, I do have to use that exact decimal. Okay, example 2. So we're going to do a more difficult example now. 3 times 12 to the negative 4k minus 2 equals 72.5. So I'm going to kind of remember back to the process that I used for inverses. So first I'm going to say, is there anything I can add or subtract to the other side? Because really when I'm solving an equation, I'm doing inverse operations. I'm undoing each step until I can get to my variable. So first I'm going to go ahead and add the 2 to the other side. So that's 74.5, and then the rest of the problem is still the same. And then I'm going to ask myself if I could multiply or divide anything. If I could multiply or divide anything to the other side, and I can divide by 3. So 74.5 over 3. I'm going to go ahead and leave it like that because I know that that is not going to be like a nice answer. And then I ask myself, what can I do with the exponent? So either getting to an exponent, getting rid of an exponent, something with an exponent. And then this is where we say, okay, my variable is written in the exponent. That means it's an exponential equation. To do the inverse operation of that, I need to do a log. And so now I'm going to go ahead and log each side, and the base is 12, so I need to log base 12 each side. So I'm going to say log base 12 of 12 to the negative 4k equals log base 12 of 74.5 over 3. So I have negative 4k equals log base 12 of 74.5 over 3. Okay. So next, I'm going to go ahead and do the step where I get like inside the parentheses, because if we had an inside of the function like originally, that would have been the exponent. That was the part that like we couldn't get to. And so now I can go ahead and divide by 4. Okay, so I'm going to go ahead and type this in. I have math up, log base 12, 74.5 divided by 3, and then that whole thing is being divided by negative 4. So I would go ahead and say this is my exact answer, as messy as it is. And then if I want my approximate answer, that's negative 0.323. Those of you with the older calculators would hit the log button. You would do 74.5 divided by 3, and then you would divide that by log of 12, and then you would divide that by negative 4, and get the same answer. Okay, so if we want to go ahead and check that, then I'll go ahead and hit store, and I'm going to store that as k, so alpha k, and I'm just going to go ahead and type this equation in. And I get 72.5, which is what I had originally, so I know that I did it right. All right, and let's do one more example just to make sure that we are totally comfortable with this. So 2.8e to the a plus 6 minus 7 equals 4. So first step, when I want to undo operations, I'm going to see if there's anything I could add or subtract to the other side. So I have the 7. I can go ahead and add 7 over. So that's going to be 7 plus 4 is 11. Okay. And then I look to see if there's anything I could multiply or divide to the other side, and I have that 2.8 that I can divide over. And next I have either, an exponent to get rid of or an exponent to get into, which is what we're doing here. And so to get rid of the base of the exponent, I need to log each side. And this is an e, so that means that I have to log base e each side. So I'm going to say log base e of e equals log base e of 11 over 2.8. And we know that log base e is another way of saying ln. So what I'm going to do is I'm just going to erase these, or if you are using a pen, you can just scroll. Not a big deal. I'm going to put an ln right there. And so ln and e cancel, and that leaves me with a plus 6 equals ln of 11 over 2.8. And then to solve for a, I just need to subtract the 6 over. So here is my exact answer. And then to get my approximate answer, I don't even have to do the math up this time. I can just use the ln button. So even if you have an old calculator, you can get this one. So 11 divided by 2.8 minus 6. And so there's my approximate answer right there. And then I'm going to go ahead and store that as A so that I can type the original problem in. Recall that the E button is right up here above the ln. So I'm going to hit second ln. There's my E button. A plus 6 7 on the end, and that equals 4. So I got it right.